All right, so we're on page 3, so everyone make sure you're on that third page of this problem that's up here now. And I think about 2 tables kind of picked it up. You kind of saw where I was going with this one, not I, but where you were going and kind of how to use the pattern of the equation to generate more ordered pairs. So now looking at this equation, what is the first ordered pair I can use? The y-intercept, right? What is that? What's the ordered pair for the y-intercept? Perfect, right? So let's write it down, 0 and -13. So everyone's writing this down on that third page. Now I think almost all of you had that. So at least I hope you would look at that and know right away that's the initial point you can use to plot for this equation. But now what I want to do is that I'm going to take that ordered pair, and then off to the side I'm going to write the slope, which is 3/5, right? So the slope is 3/5. Now slope is 1/what? Like what is it? Slope is rise over run, right? So let's write that down, rise over run. And the rise, right, because you have an ordered pair of x and y for any point that you plot, right? So does the rise, does it affect the y or does it affect x? What does the rise affect? The y, right? Because it's rise, it's your vertical movement, right? So the rise is your change in y, and your run is your change in x. So the pattern tells you exactly which part of the ordered pair you're going to affect and how it's going to use the pattern. So now for the rise, I'm going to have to add 3 to my y. So I'm going to add 3. And then for my run, I'm going to add 5. So now, class, what's -13 plus 3? -10. 0 plus 5 is 5. So now that's our second ordered pair. So I use my y-intercept, right? So if I said graph it, you would apply the y-intercept. You would have went up 3 to the right 5, right? No problem at all. I'm doing the same thing right now, but now this is a little more exact. And I'm going to show you when we get to page 54 why we're doing it this particular way. Now let's just keep going again with the pattern. Plus 3, plus 5. That's -7, and that's 10. So I'm putting a box around the ordered pairs just so I can separate the ordered pairs from the pattern. I'll just do one more. Plus 3, plus 5, that's -4, and that's 15. So I'm done for here. All right, so now you want to write those ordered pairs down. Well, you already have them on your paper. Mine was off to the side. So I have my 0, -13, 5, -10, 10, -7, and 15, -4. So you want to go ahead and plot those 4 ordered pairs on your paper. So plot those on there now. You want to get a ruler because you're going to have to connect these points. So can somebody from the table get rulers for the table? That'd be great. Don't worry about it. So we're going to plot it. 0 and -13. 5 and -10. 10, -7. And what's the last one? 15, -4. Oh, I can almost do that. I'll make that work. Hey, right now, a lot of your conversations have just now went a whole other direction. Some of you didn't know how to do it. I've shown you, illustrated, and now you're off doing something else. Let's stay on this for now and complete a couple more problems doing the same thing here. So now, once you've went on ahead and plotted your points, make sure you label them with the correct ordered pairs. So I know that I have 0 and -13. What is this one? 5 and -10. This is, what, 10 and -7? Is that what it is? Yeah. 10, -7, and this is 15, -4. You want to make sure you have your ruler. Line them up as neat as possible. And then make sure you label your equation. And a good amount of you have been getting marked down on not labeling the equation. It's the detail. It's just making sure that all ordered pairs have a point Your lines have an equation. It's just making sure you have the detail. No, what happened? No. Why is it doing this? Oh, there you go. I just want to erase this. There we go. And that's what we're doing. We're going to use we're only using just the components of the equation, and that's it. We're not going to plug in any extra points, no domain function range table, x and y and t table. We're going to use just the equation itself and uncover the pattern to derive additional points.